The topic of this video is graphing logarithmic functions. Let's look at a problem. Graph the logarithmic function f inverse of x equals log base 6 of x. State its domain and range. Okay, so as with our previous videos, we're going to use what we know about the exponential function to create the graph of the logarithmic function. Let's go ahead and write down now the table of values associated with the exponential rhythm. The exponential rhythm says, for the exponential function, we have negative 1, 1 over a, 0, 1, 1, a. Let's write that. This will help us to now create the graph of the logarithmic function by swapping all of the x's and y's and replacing a with 6. So we'll have 1 over a negative 1, 1, 0, and a1. A, for this problem, is 6, so we will change the a here and here to 6. We also know that the logarithmic function has as its asymptote the y-axis. Okay, we now have everything we need to create the graph of this logarithmic function. Let's do that. Okay, let's plot our points starting with the easy ones. 6, 1, that would be here. 1, 0, that would be here. 1/6, comma, negative 1. That means start at the origin, go 1/6 of a step to the right. So you can imagine dividing this into 6 equal pieces and then just going to the first one, and then down 1. The vertical asymptote is sitting on top of the y-axis. I will draw that with a thick line so that it is centered on the y-axis, but it is still visible. And now I will connect my 3 dots to create the graph of the logarithmic function. I will approach, but not reach, that vertical asymptote. Okay, we've created the graph. Now we need to find the domain and the range. Let's start with the domain. Domain is a collection of all of the x values. Said another way, how far does the graph go to the left, and how far does the graph go to the right? Well, in this particular instance, we can see that the graph is only on the right-hand side of our graph grid, where the x's are positive. And for this reason, our domain is 0, infinity. In other words, all of the positive real numbers. Now, there is a parenthesis at 0 to indicate that we are excluding 0 from our domain. Why? Because there is a vertical asymptote at 0, meaning that our curve tries to reach 0, but cannot do so. It gets as close as it can without reaching. Therefore, we need a parenthesis at 0. It goes to the right forever, which is why we have the infinity part of our domain. All right, now we turn our attention to the range. This graph goes forever down and forever up. It's a little difficult to see that it goes forever up, but if you zoom in very, very tightly on this part of the graph, you will see that it is pointed in 2 directions. A little bit up and a lot to the right. But we don't care about the part going to the right for range. We only care about up and down. So since this is going up forever, and since this is going down forever, the range will be from negative infinity to positive infinity. We have now completed this problem.